What? Okay, now I'm recording. Hello. I'm totally thrown off now. I had a day today. It wasn't a bad day. It was a day, Things happened. Mostly it was me like fiddling about on the floor and like trying to unscrew. Like there was this rack shelf that I was trying to get out of the old one. I'm moving hardware from a shorter, smaller rack to a bigger, larger, nicer, taller one. And among other things, the old one is a fucking mess. So I'm doing that, and the new rack's too tall, or it's like so tall that like I can't lift very well the heavier stuff, which is most things for me. Um and screw them in at the same, like I can only do one thing, right? Either I'm screwing something in or I'm holding it up, right? So I had to get help. And then so then there was this screw. This is the most exciting thing that happened to me, by the way. So like today, this is the most exciting part of my day. So get ready. There was a screw in this rack that was holding up this rack shelf. I could not fucking unscrew it. So it was already stripped. Like whoever had installed it, who was not this person was not me. The person who installed all this and like put it all together, they stripped this screw, and I could tell that they definitely had issues with it besides the stripping, because like the screw was not all the way screwed in. There was a good amount of like the post where you could see the threads and stuff, and they had like tried to put like a, it's either a nut or a bolt or whatever, like the flat thing in between the screw and the, anyway, they tried to put that on there, but it was just like loose flapping around because the screw hadn't been fully screwed in. So I had to try and get it out. I tried so fucking hard. I bent a flathead just trying to, you know, um, it just would not fucking come out. And if I used the actual like Phillips head that was, made to do this, like it stripped it more. So I tried pliers. I got out these really beefy pliers, right? It was like holding on and like, "Urgh." And I bet I could have done it, but the metal was so soft or whatever, and the screw, that it immediately just fucked it all up on the outside, and I was afraid I was gonna fuck it up more. Anyway, I ended up asking like three different other people for help, and finally the third one, God bless him. This man was like, "Oh, no problem." Just like a skinny dude, He's like, "No problem. I work on cars all the time." And I'm like, "Yeah, all right, we'll see." And he fucking breaks the head off of the screw, which, you know what? It got the rack shelf out of there for me, so it worked. It was awesome. So, you know, get a drill to like get that, um I don't know if you call it the post of the screw or what that is, the straight part, but whatever. Anyway, they're gonna drill that out. But that was the most exciting thing that happened to me today. I couldn't get a stripped screw out, and finally someone else got it out for me. So, so my day is really going up if I'm reading about Ethernet. Good night, good evening, good afternoon, good morning, wherever you are. Hello, everyone. Is there really a stream of a jar of peanut butter just sitting there on Twitch? That's actually, see, that's more, it might not be more exciting, but I think it's more interesting for sure than this stream. Oh, some people install with power drill. I hadn't thought of that. Why am I not using an electric? Whatever. Anyway, it doesn't matter. I got it out, and I'm pretty sure I'm going to be able to get everything else out. Knock on wood. So now it's just like, okay, how do you fucking, I've never built a rack before, so this is quite the learning experience. And it's really not like fully building it out from scratch at all, because somebody else already set up and configured and sort of like put in cables and connected things. And so I'm sort of doing like this like, I don't know. I'm like going back in time, trying to like figure out what they've done, why they did it, what the hell they were thinking when they did it this way. And as I put stuff in the new rack, I'm gonna sort of try and optimize, but honestly, like I'm afraid to fuck anything up. So everything is like temporarily labeled, and I'm just fucking unplugging things at this point and slowly and like I think I've figured out the way I want to arrange things a little bit differently in the new rack, but that's as far as I'm going right now with changing it up. Cage nuts are the devil. You know what? I was really annoyed about having to install cage nuts, but they've grown on me. They've grown on me. They look nice. They make it look nice. And I like that. And if you use just a little flathead screwdriver, you can pop them in pretty easily. Um but yeah, this rack is so big that I like can just sit down comfortably cross-legged inside of it and like hide from everyone. I can close the little doors and then just I have my cage nuts and I'm just popping them in. It's fun. New racks because they wouldn't fit our 9500s. Oh, okay. Gotta get new shoes because you're no. Gotta get bigger pockets because all your diamonds won't fit in them. No, the 90 aren't all the 9Ks huge except for the well, maybe not. I'm thinking of the like 94, 5, 600s maybe. I don't remember. There's so fucking many of them at this point. Uh Sounds like someone used a drill to screw into the rack. Yeah, it could have been. It could have been. I cannot answer for this person. They are no longer at the company, and I, had a hard enough, no more comments. I need to stop. Um, oh, cage nuts suck to put in, but they're a lot easier to deal with than a cross-threaded rack screw. I can see that. Ooh, an insertion tool for caged nuts, but if you slip, ugh. Oh, really? Is it gonna like cut off your finger or something? Okay, so the 9500s need a 4-post rack. Hang on. I don't know anything about like racks. I I've never built one, like I said, so I don't know what the fuck I'm talking about, but I thought they were all like 4-post racks. You have a post and a post on one side and you have 2 posts on the other side. I thought that was 4 posts, but now I'm confused. What's a 2-post rack? Maybe. Oh, does that mean like mounted on the front and the back? I don't know things. 2 posts, just the front. Oh, I see. Yeah, okay. So you're just mounting it on the front 2 posts, whereas some heavier stuff you mount on the front 2 and the back 2. Okay, yeah, yeah. I the shelf that I was pulling out is like that, but it needs some adjusting. So I'm just glad I got it out of there. Anyway, let's talk about Ethernet. Um, I was trying to remember where I left off last time. I'm pretty sure it was auto negotiation. We did talk about parallel detection and duplex mismatch. What happens? Nothing happens, basically. Let's see. Oh, I don't think I remember this. We have the results of auto negotiation and parallel detection combined with manual configuration for link partners. So that's good to know. Speed and duplex auto, you're gonna get 100 FDX. Wait, what the fuck is FDX? Did I miss this? I might have missed this. Mhm. If a switchboard is manually configured for full duplex mode, and if manual configuration also shuts off auto negotiation on that port, then parallel detection will set an auto negotiating interface connected to that port to half duplex mode, creating a duplex mismatch on the link that will result in lost frames and low performance. Really? That doesn't seem right to me. I feel like but that really doesn't seem right to me, but maybe not. maybe I'm wrong. I'm not gonna act like I'm the expert. That's why I'm reading a fucking book about it. I'm gonna look this up. I'm probably mixing this up with like LACP and PAGP port states or something. I don't know what I'm mixing up with. Auto negotiation with manual configuration. 'Cause the reason why auto negotiation is fascinating to me, but one of the things that bothers me is like what happens. Well, no, this is a little bit different. Never mind. Is if you configure auto negotiation manually, that implies that you are turning off the advertisement part, because that's what auto negotiation is. Part of it's an advertisement to the other side, right? And it's a negotiation. But if you're not, well, no, okay, now it makes sense as I talk through it, because then if you're using auto negotiation on one side, then you're waiting for a negotiation to happen. But if the other side manually is set to no auto negotiation, so there's no negotiation happening really, then, the side waiting for the negotiation is just gonna be like, all right, well, no negotiation, so we can't do anything. I guess that's how it goes. At first I was kind of thinking it made more sense for auto negotiation to go, okay, I'm going to actually match whatever that manual config is, but I'm mixing it up with that, like, match the speed that auto negotiation wants to do with the other side, if the other side like has a lower speed capability or whatever, right? Yeah, and maybe also throw in there like some confusion surrounding like LACP and PAGP, because all of that sort of melds together for me these days. I haven't had to think about LACP in a while. That's sad. Ugh. Anyway, used to work 72U racks. How does it even work? I didn't know that exist. Do you have to get on a ladder? Holy shit. 72. Well, okay, I'm coming from the perspective of being very short, but like 72U is very tall. That's very tall. Keep a step stool. Yeah, you know what? I need a step stool pretty much for this 48U. Almost. Almost. Anyway, whatever. It's really nice to have like space to be like, okay, this many U's is for this switch, this many U's for these switches, these many U's for such and such. Here's the managed PDU. It's nice to be able to plan that out. I like how everything is like labeled, like, this many U for like these holes, this many U for these holes. It's very nice. I find it very soothing, all the labeling and flexibility that a really good rack offers. All the different holes for different screws. Oh man. A sweet old school sliding ladder. Yeah, I'm thinking of in Beauty and the Beast, if you remember at the beginning when she's like singing the song about this provincial life or whatever, and she's like in the bookstore. I think it's that one. I think that's the song. She's singing a song, she's in the bookstore, and she jumps on this ladder and like slides real gracefully to like across it, all the books and shit. Am I just mixing it up with when she's in the cat? Whatever. There's a scene in Beauty and the Beast that's really like awesome that every book nerd who like grew up in that era like fucking loved. And it was like she jumps on a ladder and like sails gracefully along the books, right? Anyway, that's how I imagine it in a huge data center with 72U racks. I don't know if that exists, but it sounds fun. That's my library dream right there. Huge, huge server racks, just as far as the eye can see, a la Beauty and the Beast. I jump on a ladder and it just slides across all of them. And I hear the rush of the fans as I go by. Oh, I'm tired. I'm so tired. Okay. A special server elevator on wheels. Some of the racks we deploy are now 4,400 pounds. Holy fuck. Can only imagine what you got on there. A tour of one of those huge data centers. I don't know. If you've seen one data center, you've seen them all. Although I will make an exception for like the ones that are extremely automated and almost all their processes and turnups and things. So that would be like what Facebook and I don't know, AWS data centers would be. That would be cool to look at. Um, Server lifts makes installing gear really easy. Yeah, fuck. I don't have that shit. You know what I have is sweat, blood, and tears and some screwdrivers. No automatic, no electric anything. And only some help sometimes. Be proud of me. This is my first time building a rack. I've never really mounted anything or did any shit. I'm a network engineer. Yep, I'm a network engineer. And I've never ever done any of that shit. I did crimp my own cable when I was in Cisco Netacad. Thank you, Cisco Netacad. That was fun. But that was one time. So it's not that impressive in the end. Okay, I'm reading about Ethernet. Fuck. Yeah, okay. The parallel detection system is required by the standard to default to half duplex mode in 10 and 100 megabit per second systems because an auto negotiating device that is using parallel detection has to set some duplex mode, and half duplex is the safe assumption. Given that 10 and 100 megabit per second equipment must support the original half duplex mode of Ethernet operation to be compliant with the standard, and given that support for full duplex mode is optional, selecting half duplex as the default mode of operation was the only choice left to the developers of the standard. We got a little footnote. When selecting the highest common denominator through parallel detection function, only the half duplex mode corresponding to the selected PMA may automatically be detected. Oh, sorry. I'm confusing footnotes with like actual interesting information. Okay. So this table shows the results of auto negotiation and parallel detection combined with manual configuration for link partners with 10 100 megabit per second capabilities. Okay, in that table, link partner A is not shown but is assumed to have auto negotiation enabled for both speed and duplex. We assume the worst case implementation choice on the part of the vendor, in which auto negotiation is disabled for any Ethernet interface that has been manually configured for speed and or duplex. I'm a little confused by that sentence. So here we're assuming the worst case implementation choice on the part of the vendor, which is that auto negotiation is disabled for any Ethernet interface that has been manually configured for speed and or duplex. Is it not generally implied that auto negotiation is supposed to theoretically be disabled if you are manually configuring speed and duplex? This does interest me because the world is not, even the IEEE standard is not that clear on some things when it comes to Ethernet, and auto negotiation is one of them. So it seems the context of this paragraph sort of seems to be giving me the impression that it is optional in the standard for vendors to disable the auto negotiation process on an interface that's been manually configured. I mean, like, how would auto negotiation even work when it's and this is where my question comes in. Let me see if I can phrase this well-ish, clearly. What are you actually doing with what's happening when you are on like one of the big vendors, right? When you're on a Cisco switch, for example, and you're saying, speed forced whatever. I forget the duplex command. It's probably just duplex whatever, right? But like, what's actually happening there? Are you saying is that disabling auto negotiation when you do that? My theory is it's not. And Like, I'm pretty sure it's not. So if you're not disabling auto negotiation when you do that, why is the book like, hey, let's just assume that the vendor did disable auto negotiation, and they call it the worst case scenario? There's so many things I feel like that need to be unpacked here, and I have so many like, do not all vendors disable? Why would it be optional to disable auto negotiation when you've manually configured? And if it's not, right? If it's not optional, hang on. So yeah, it it seems as though we're not actually, when we, on most vendors equipment, maybe this is how stuff happens, like we're not actually disabling auto negotiation when we're saying speed force 1000 duplex full or whatever. It seems like when we do that on most vendors equipment, we're actually just passing parameters into auto negotiation to force it to negotiate and advertise speed 1000 duplex full. And that's because we're not specifying the master slave ever in any of these like processes, right? It's always speed and duplex, but we're never saying who's master or slave, or leader, follower, whatever you prefer to use terminology wise. But in auto negotiation, one of them is the leader and one of them is the follower, and that's how it works, right? They either negotiate that, or if you've turned off the negotiating of it, you have to tell it that manually, theoretically, right? So why aren't we ever specifying the leader follower roles? Yeah. Yeah. So this paragraph kind of freaks me out, and I have many questions about it. Yeah, this is the everything is auto negotiation theory that I mentioned on Twitter earlier. D Chateau, you are correct. Hi, Malgort. I love that. That's great. Malgort, welcome. A new network study Twitch channel. Does that mean that you are a network person? Because that's awesome. Now, see, I'm gonna get on my fucking auto negotiation soapbox. It doesn't all. It's up to. It seems very heavily. I think it's up to the vendor as to whether or not they any given device they have manufactured, whether or not it actually disables auto negotiation when you say speed forced 1000 duplex full or whatever, right? Because why aren't we doing the master slave, the leader follower configuration? We're not ever. Well, I'm not the most experienced network engineer, granted, but like I've never heard of setting that role on most equipment. So, see, that's what's happening is you're still advertising stuff. You're just, when you tell it one speed 1000 duplex full, you're forcing it to only advertise. You're forcing it to advertise 1000 duplex full to the other side and nothing else. And I guess maybe not come up for anything other that, like, it can't settle on that lowest common denominator, probably. Like, I'm guessing that forces it, like, it can only settle on speed 1000 duplex full. And so it's like, it is auto negotiation, but it's like a very restricted form of it, is what it seems like. Electronic engineer. Okay, Huawei and JNCIS SP. Very interesting. No. It does not disable it on Cisco iOS. And if there's somebody from Cisco on this call who will look into this for me, because I've been desperate to find a piece of vendor equipment that fully and truly disables auto negotiation by way of we allows us to specify the leader and the follower roles, that master slave thing. I have yet to find a vendor who can do that for me. I cannot find a vendor who will find that. And I've asked them. It has been asked of them, and no one has come back with results yet. So it does not fully disable auto negotiation. And let me be clear, when I say fully disabling auto negotiation, what I mean specifically is no advertisements of any kind. Auto negotiation works with advertisements. It advertises link, speed, and duplex and everything to the other side and vice versa, right? That's how it works. It's auto negotiation. You cannot have in part. Otherwise, if there's any kind of negotiation, any kind of talk of negotiating at all back and forth, these advertisements, that is auto negotiation. Even if you're forcing it to only negotiate one thing, it's still negotiating and it's still advertising. So it's auto negotiation, even when you say that speed 1000 forced or whatever command, right? And I also know because, well, I haven't personally seen it, but you know, things I've heard, I have it on good authority that you can disable auto negotiation fully. It just depends on, like, if the vendor of the device didn't allow for that to happen, then it just can't happen on that device, of course. But like, it's possible to run, you know, without auto negotiation fully on a device. You just, depends on the device. Anyway, that's my auto negotiation soapbox. Thanks for coming to my TED Talk. Back to the subject matter at hand. Auto negotiation and parallel detection. I feel like I've been in a fever dream and I never really fully understood what parallel detection is. Oh, yes, no, I do. It's how it works with 10 and 100 megabit per second twisted pair interfaces that don't support auto negotiation. So let me just review on this because I remember reading it, but it has to do with the link pulses. Okay, so auto negotiation can understand, like, if it doesn't get the fast link pulses, that mean it's another like AN capable interface. If it doesn't get those and instead it gets the slower ones, that mean it's like the older 10 or 100 megabit per second systems without that auto negotiation support. It knows that it knows that that's happening, and then it will work with the other side anyway to settle on its lowest or highest common denominator, right? But you can't exactly do that with 1000 base TX and 10G base T interfaces. And it says 1000 base T devices must always be detectable via auto negotiation, and parallel detection is not needed for their operation. That's 1000 base T, which is gigabit copper. Excuse me. All right, so that's parallel detection. Okay, so if a switchboard is manually configured for full duplex, and if manual configuration also shuts off auto negotiation on that port, so again, we're talking about, it talks about manually being configured as a separate thing from actually shutting off auto negotiation on the port. Strong evidence for me. Anyway. Okay, then if manual configuration also shuts off auto negotiation on the port, then parallel detection will set an auto negotiation. I can't not say auto negotiation. I don't know why. Auto negotiating interface connected to that port to half duplex mode, creating a duplex mismatch on the link that will result in lost frames and low performance. So once again, we have a switch port that's manually configured full duplex, but no auto negotiate. It is actually disabled. It's fully disabled. There's no advertisements, nothing. Okay. Parallel detection on the other end, assuming the other end is auto negotiating, it has parallel detection going on, and it will see the no negotiating, but it will set it in half duplex mode because that's the best it can do in that situation, right? And then, of course, this failure mode is a major reason why you should avoid manual configuration whenever possible and let auto negotiation handle the task. It's true. In most cases, you should, but not all. Mulgort, I am not studying for a particular exam with this book that I'm reading right now, this is just kind of like for fun and edification because I realized that I don't know, as a network engineer, I've taken Ethernet for granted. I didn't know all the features that it had. I kind of just was for a while when I was studying for my CCNA, I just thought it was just like a type of cable because people talk about them, right? Like there's Ethernet cables. I guess it technically, I mean, it's the twisted pair. You can call that an Ethernet cable, right? But I thought that that's all it was, right? It was just a type of cable. I didn't think of it as a protocol, and it's really a protocol. It's a technology. So yeah, good to refresh on the basics, basically. And I'm interested in getting into the, you know, layer one aspects of it too, if possible. Okay, so worst case implementation choice on the part of the vendor in which auto negotiation is fully disabled for any Ethernet interface that's been manually configured for speed and or duplex. So here's what'll happen. Let's see. 100 FDX. Oh yeah. I don't remember what FDX or HDX are, but like I assume that's like, you know, or 100 megabits per second type of thing going on. So we have one side at auto negotiation, the other side is automatic configured speed and duplex. Oh, actually, auto and auto. So that looks like this is our sort of test. This is our control case. We have auto negotiation on one side and auto negotiation on the other side, and that results in what we want, right? If both of them support 100 megabit per second and full duplex operation, this is what we're getting, 100 FDX. If we have our one side auto negotiation, but its link partner, so on the other end of the, you know, the port on the other end, it's manually configured for speed 10 and duplex half duplex. Wow, I just finally fucking realized what HDX and FDX mean. Cool. So it's configured manually for 10 10 megabit per second and half duplex. Then the result will be 10 half duplex. Hooray! Because that's like the lowest it could be. And auto negotiation is like, okay, whatever, I'll just try. If we have 10 speed configured manually, but we're at full duplex, then auto negotiation again is just in response to everything. It will have put it into half duplex. And so we're gonna have a duplex mismatch because we have one side half, one side full. And then so on and so forth, right? Like we can do this forever, right? Basically anything that results in half duplex will not be a duplex mismatch, but anything that is like manually configured, fully disabled from auto negotiation, full duplex, and then the other side's auto negotiate, then we're going to have a duplex mismatch because auto negotiation apparently will always put itself, you know, that port that it's on into half duplex if it doesn't see advertisements from the other side, basically. I'm assuming. On the assumption that manual configuration disables auto negotiation, which is, again, they remind us the worst case vendor implementation. If one link partner is manually configured for full duplex operation and the other isn't auto negotiating, the result will be a duplex mismatch. Even working correctly, the resulting link will be misconfigured due to the combination of manually configured duplex and lack of auto negotiation on one of the link partners. Although not shown in the table, if both ends of the link are manually configured, which means no auto negotiation on either side of the link, and if the manually configured duplex settings at each end don't match, you're still going to have a duplex. Well, duh. Okay. If manually configured speeds at each end don't match, then there will be no communication possible at all. Okay. My throat gets so dry when I talk for even like 20 minutes. Yeah, for those kinds of topics, I think it's good to try some configs on a virtual lab. Yeah, it would be, but like, what am I going to do? Configure Ethernet on like a virtual cable? I don't know. This is really just for fun. I wanted to know the in-depth like layer 1 stuff about Ethernet. So it's kind of hard to lab that up. But yeah, for exams, labbing is great. Labbing is definitely good. Auto negotiation completion timing. The documentation for 10, 100, or 1000 megabits per second Ethernet transceiver provided by a major chip manufacturer notes that the processes of parallel detection and auto negotiation take approximately 2 to 3 seconds to complete for our 10 or 100 megabit per second devices and 5 to 6 seconds to complete for 1000 megabit per second devices. So 1 gig, you're talking 5 to 6 seconds. That seems like a long time to me. For, I don't know. This book was also written in 2014, so take that with a grain of salt. Auto negotiation with next page can take an additional 2 to 3 seconds to complete, depending on the number of next pages that are sent. These are typical timings, which provide a rough idea of the amount of time that you can expect auto negotiation to require. By default, most vendors ship switches and Ethernet interfaces with auto negotiation enabled. Leaving auto negotiation enabled on all ports connecting to desktop computers is an effective way to avoid problems with duplex mismatch. However, it's still possible to encounter equipment that doesn't support it or that may have software bugs that may require disabling auto negotiation. Auto negotiation is debugging. Debugging is described later in the chapter. All right. Okay, to sum up, modern Ethernet devices support multiple speeds and modes of operation and are therefore more complex than the original system. The auto negotiation protocol makes it possible for link partners to automatically discover and configure their highest common mode of operation despite all the possible speeds and options. However, auto negotiation may not work successfully if the device at one end of the link is manually configured for full duplex mode and if that configuration disables auto negotiation support on the device. In that case, if auto negotiation is enabled on the device at one end of the link and manual full duplex is configured at the other end, the result will be a duplex mismatch that typically causes high frame error rates and lost packets. This can be avoided if the vendor provides an implementation of auto negotiation that continues to operate when speed and duplex settings are manually configured. Anyway, I think I'm going to end it there. This was a pretty short stream, but my voice is just having trouble. Man, last time I ended early because I was like feeling dizzy or something, which I never figured out what that was, but I'm fine, right? And this time it's because my voice hurts. So I don't know. Let's hope I get my shit together in the near future. Anyway, thank you all for joining me. It's always nice to talk to anybody during a stream, frankly. It helps me learn. So I hope you'll have a great day or evening or sleep or whatever. I'll be back here. I am going to stream every Monday, even if I'm a little bit late. Even if it takes me an hour longer to get here, I will stream on Mondays. If some kind of emergency happens and I'm not going to, I'll just tweet it. I'll put it on Twitter. So anyway, you can find me. You see my handle down below. Track Pacer. I'm Track Pacer everywhere. Just search for me wherever. You'll probably find me. Anyway, I love you. Goodbye. Have a good day or evening. Adios.